Hello, this is the summary for the E516 class. My name is Gregor von Laschewski. Let me introduce you to some research topics that I'm doing. I'm mostly interested in cloud computing. As part of cloud computing, I'm working a lot on cloud computing architectures together with the NIST Big Data Reference Architecture Group. I'm also interested in federated cloud computing. And as part of this one, I'm currently looking into multi-cloud and hybrid cloud architectures and tools, while we are developing a tool that can submit easily to Amazon, Azure, Google, and other clouds. I also am interested in how we can enable high-performance computing in the cloud. Another topic that I'm currently doing is this cloud and edge computing. How can cloud computing support edge computing? Here I have even an autonomous robot boat example that we allow residential students to work on. And what that is you have actually a boat that is sent out to a lake and it takes some environmental measurements. I'm also interested in environmental other sensors that are connected to the cloud. Big data applications are naturally of an interest, where we do, for example, scientific impact analysis on 60 million bibliography references. I also would like to see someone to collaborate with me on monitoring and cloud visualization, so that we can develop, for example, a cloud portal for cloud mesh. With me, you not only have the opportunity to conduct research, but you can participate in active research activities such as, for example, NIST or other activities. And you not only learn theoretically about it, but you learn practically about it, because we will be engineering certain cloud frameworks. The communication in the class is rather simple. We're using a very small set of tools. As we are a cloud class, we rely on cloud services for this particular class. And one of our main communication tools is Piazza. This is like a chat room in which you can ask questions and we answer these questions. This has been approved by Indiana University, and it's one of the approved tools and specifically suggested for this kind of a class, as other tools such as Canvas are simply not powerful enough to support this class. We have GitHub, in which we are storing our artifacts, such as the programs and maybe even articles that we are developing. And typically, you do not send us email to my email addresses. Instead, you will be using just Piazza to ask this question. In case you have something personal to ask, you can send them to gvonlars@iu.edu. And we make a decision what to do, or you can use the Canvas email system. There's absolutely no emails to TAs, and they are actually forbidden to answer you via email. They are only allowed to use Piazza for communicating with you. And anything that requires personal stuff, just please send it to me directly. As part of this class, we will define what cloud computing actually is. We will be revising and revisiting the NIST definition that is being given. We will look at the history of clouds and which technologies enabled clouds. In particular, we will be looking at the service model that promotes infrastructure as a service, platform as a service, and software as a service. Naturally, for the cloud, we need actual hardware. And as we are talking about big hardware and lots of hardware, they're typically moved into data centers to share the resources with other users. And we will be going into finding out how such data centers evolved, how a data center looks today, what's the difference between an academic research center, and where we find actually these resources all over the world offered by different vendors. Naturally, when we are trying to define multiple different applications, we want to share actually components with each other that are part of a unifying reference architecture. This is being achieved while we are looking at commonalities that are being identified by NIST so that we can define composable services. As such, we will be having a chapter about how we are using the NIST Big Data Reference Architecture, not only how we are using it, but how we extend it and define it. And you can become actually a co-author of that particular document if your contribution is being accepted. This is naturally a very unique opportunity, and not everybody has this opportunity, and I hope that you enjoy that we are making this available as part of the class. A significant portion of this class will deal with infrastructure as a service, and we will be providing you first with what the definition is, how we manage infrastructure, how do we use infrastructure, why we are using command lines, why we are using GUIs, why we are using programming and contrast each other. We provide an overview of commercial and educational infrastructure as a services. In particular, we will be going into some architectural and vendor-specific provider offerings. This include OpenStack, Azure, Amazon Web Services, Google, and potentially Watson, but we may not have enough time. Possibly we don't even have enough time for Google. We will see how we proceed throughout the semester. A significant important technology for cloud computing is virtualization. We will be introducing you to the different concepts of virtualization, which include machine virtualization and container virtualization. As part of the machine virtualization, we will be looking at QEMU, KVM, and virtual machines. Within virtual machines, we will be practically using VirtualBox. As part of containers, we will be looking at Docker, how we use Docker, how we define Docker files, how we use Docker Hub, and how we create our own Docker images. In addition, we will be looking into Kubernetes as well as Docker Swarm. Any class in cloud computing would not be complete if we were to be practically trying out cloud computing. In order to do this, we have to learn about how do we program it. And we have decided to not use Java, but we decided to use Python, as Python is playing a gigantic role nowadays in big data, as well as other programming activities related to cloud computing. For that reason, we will be giving you a short introduction to Python for cloud computing that includes the differences between Python 2 and Python 3, an introduction to Python as a language itself, how do we classes, and how do we use special packages that are extremely beneficial for our project. Within this class, this includes docopt, CMD, and CMD5, YAML, JSON. We will be going into how do you do module management to create your own modules. We will be teaching you about how to do a setup.py for your project, and how you host your code on GitHub and install the code from GitHub. As part of your project, the TAs are required to use your installation mechanisms from GitHub to run your code. To access the cloud, we will be using libcloud, which is a hybrid cloud library to access multiple clouds, and showcase you how you can manage your clouds through libcloud. We will be introducing you to REST services, and as part of this introduction, we will be showcasing you first how, for example, GitHub uses REST services so that you can understand the mechanisms. Then we will be developing our own REST services with Eve, which is a simple way of defining REST services. And then we will be using a mechanism so that we can define REST services through an open API specification, so that you not only can develop and export them to Python, but any arbitrary programming language. One of the programming models used in cloud computing has been popularized early on in, for example, Google, And this concept is called MapReduce. We will be teaching you about what this concept is and how you can use this. And then we will be outlining differences between different systems, such as Hadoop and Spark, which are using MapReduce concepts. Another concept is that we need to be communicating with the cloud and the data services in the cloud. Therefore, we often use messaging. We will be introducing you to a state-of-the-art messaging framework called MQTT that can be used easily to forward messages between clients to cloud services, but also from the client to access information from the cloud services. Thus, we have a publish subscriber module that is supported by, for example, MQTT. In addition to REST services, most recently the term GraphQL has come up as one of the important technologies that we need to be researching. And this section introduces you to GraphQL, which is essentially a query language for graphs, and showcases you the advantages and disadvantages of GraphQL in contrast to other frameworks. One of the important activities at Google, for example, is to use Go for cloud computing. Go is a language that provides performance to you, and it's easily accessible to you. It allows you nicely to create REST services and interfaces with containers quite nicely. Go allows you to run your containers on Kubernetes easily, and we will be showcasing you how to do that and how to write simple programs in Go. This may be potentially useful for some of your projects because some of them you could be developing in Go if need be. Please consult with me if you should be choosing Go or Python. Typically, Python is easier to use. Cloud computing deals with big data and big machines, so lots of computing power and lots of machines to execute them and lots of data. In order to achieve lots of data, one other possibility could be achieving is that you, for example, look at all the cell phones that are out in this world or all the sensors that are out in this world. And this is where edge computing and the cloud comes into place. How can we utilize these particular services and information pieces to use them in an analytic fashion within the cloud? So we will give you an introduction to how cloud computing and edge computing work together. We showcase this, for example, on a Raspberry Pi as an edge device. We are streaming data from the Pi, attach sensors, and you can participate in a project as part of the autonomous robot board that we are creating.
Some fun projects that you may be able to engage with us is, for example, the activity to help us developing an environmental robot boat. This robot boat has actually its propellers over the air and flies essentially over the lake and takes some environmental measurements. Another thing would be to develop our Raspberry Pi cluster. We have up to 200 nodes available here at Indiana University, but you can also do this remotely with, for example, 3 to 5 Raspberry Pis. And as part of this, we also are interested in the design of a case. So if you have Maker Lab experience, that would be something you can help us with, as well as the improvement of the boat itself. We have a number of assignments for this class. The number of assignments is actually relatively small, but they typically require some time to devote. One of it is our weekly labs. This is a new activity. We used not to supervise such weekly labs and had them done on voluntary basis, but we found out that most students did not do them and only spent time on other classes and then did poorly in their projects. Therefore, we will be this year introducing weekly labs that are being graded with a pass-fail and will be integrated into the final grade. You will be reporting your activity that you have done on a weekly basis in a notebook once you have your GitHub repository set up by us. The first thing is you will introduce yourself to the class with just a post of a formal bio that may help you finding also partners for your projects. One of the main activities is that you contribute to the book that to the books that we are distributing throughout the semester. And we are looking here for chapter contributions, either improvements, significant improvements to existing chapters, or new chapters. This year we will probably focus on AI services in the cloud, so there will be many opportunities for you to participate in that activity. This activity can be done on a weekly basis, and we will be integrating everybody's contribution in a new chapter. The main contribution of this particular class that you will have to deliver is a project, and the project naturally must be related to cloud computing. And we have a variety of types of projects. The first one is probably the easiest one to choose, and many students actually do choose this, where we develop a multi-cloud environment that's called Cloud Mesh, so that you can easily submit virtual machines or access data on different clouds such as Amazon, Azure, Google, and others. The next one would be the development of a cloud cluster based on Raspberry Pis. And the reason why this is actually interesting is because you have full control over the hardware. And there we would then look into things such as deploying Kubernetes, Hadoop, Slurm, and Open API REST services. We also have another project where you will be building REST services based on Open API. This is not as this is actually a very straightforward project. However, it has to be done correctly, so you will need to engage with us in guidance on how to do that. Other activities include edge devices to be integrated into the cloud, such as, for example, our robot boat or air quality sensors. And last not least, we need to be mentioning that you can certainly develop your own services. And since we do one of our focus areas this year to be AI services, we would like that you develop cloud AI REST services and expose them to Open API and contrast them to offerings provided by other clouds. Here we would like to see if it's not possible to create maybe a multi-cloud AI REST service. If, for example, Amazon offers one service and Google offers the same service, why not create an API that can submit to both, and we integrate this into Cloud Mesh? And this kind of a project would also qualify for you to not have to write immensely long text about chapters, because you will immediately start programming. All projects must be reproducible and include benchmarks. We will be using PyTests for making sure that your programs do work. The write-up of your project or the chapters is relatively straightforward. We will just use Markdown. We have provided in our books and in a specific book lots of hints on how do you do that, including tips on improving your write-up. And these skills will be extremely useful for you for any other class. Previously, we have used LaTeX. However, we found that a number of students were overwhelmed with learning too many new technologies. So we are just using Markdown, which is a very simple way of creating documents that can even be done online in GitHub. We have a number of TAs that can help you and assist you with your projects as well as your questions. Please ask your questions on Piazza. You do actually get credit if you answer questions that other students have. The Piazza has two different areas, one for the instructors and one for the students, where both can develop answers to the question. And if you see that you are performing very well there, this is some way of you to get very easily credit. And one of the things that we actually do have as a principle of mine is this: read things twice before you do it once. So this is, the R2D1. So this is not R2D2. This is R2D1. Read twice, do it once principle. And we found that pretty useful. We had in the past students that did not read at all anything that we have distributed to the class, and those students should not be surprised if we ask them to read the appropriate information. Thank you so much, and don't hesitate to engage with us in questions.